students, welcome back to the channel. Get understanding, don't memorize. Yes, this is the continuation of our series of lessons on binary operation. We are still in further mathematics or elective mathematics. Yes, binary operation in further mathematics or elective mathematics. We are still looking at the properties of what binary operation. So this is the continuation of properties of binary operation. So in this video, we are going to look at the distributive property. Oh, remember, we've already considered two properties: the commutative property and the associative property. Yeah. So we said that the commutative property involves what? One operation. Let's say one operation triangle and what? Two elements. One operation, and what? Two elements. And what? And we also consider the associative property. Associative property also involves what? One operation. Involves one operation and what? And three elements. One operation and what? Three elements. These are very important parts to clarify things for you. This distributive property, distributive property also what? Involves what? Two operations. Distributive property involves two operations. Three elements. So you have to note that two operations and what? Three elements. Okay, so let us look at what the distributive property says. It says that what? If two binary operations, square and triangle. If two binary operations, square and triangle. So as we see, we are using two operations, as I said. If two binary operations, square and triangle, defined on the set S are such that A square into bracket B triangle C is equal to what? A square B into bracket or triangle into bracket what? A square C for all A, B, C belonging to the set, belong to S. Then we say that the operation square is distributive over triangle. So how here you have to know which operation is distributive over which. You have to know that is very, very important. Okay. So I'll use multiplication to explain for you and to understand. It's very simple. It's very, very simple. Okay. Fine. So we are saying that normally if you define the operation, you define a binary operation so defined with respect to a set. So here if you have a set S and then we have two binary operations defined on this set or with respect to this set, such that if for every three elements we take from this set, if for every three elements we take from this set under these two operations, or using these two operations, square and triangle, if what? A square into bracket B triangle C is the same as what? A square B into bracket then triangle into bracket what? A square C. For every three elements we take for every three elements A, B, C we take from the set S. Then you say that the operation square is distributive over triangle, over the operation of triangle. So know it very, very well. No. So if you want to understand, then let's use the multiplication to what do you call it? Let's say if you have this, if you have, let's say 2 into bracket 5 plus what? 5 plus, let's say 5 plus 1. If you want to do this is the same as what? This is the same as 2 times what? 2 times 5. 2 times 5 then plus what? 2 times what? 2 times 1 is the same as this. Have you seen? So over here you see that this is the multiplication. We are distributing this multiplication over addition. We are expanding. You see the multiplication is what? Outside, then the addition is inside. So if you expand, then we get multiplication. You see multiplication here, then we have one addition. So it means we are distributing the multiplication over the what? Over the addition. Have you seen? So this is the same as 2 into bracket 5 plus 1 is what? 6. 2 times 6 is what? We get 12. And this is 2 times 5 is what? 10. Then we have plus 2 times 1 is 2. We also get what? 12. Have you seen? So since this is equal to this, we say that multiplication is what? Is distributive over what? Addition. So this is with respect to, let's say, respect to rational numbers or with respect to what? The set of real numbers. We can say that multiplication is distributive over addition. So look at how which is distributive over which. Don't get confused, because here you see this multiplication is outside and this addition is inside the bracket, and if you expand, we are distributing this multiplication over the addition. At the end of the day, you know that the one which is distributing over the other has more, the appears more. So here the multiplication is appearing how many times? Appearing 2 times. And the addition is also appearing only once. So in the same way, this is what we have here. We have this one, we have this operation, and this into bracket. So if you want to expand, then you can have this one, this square b, you have this one, then you bring this one, then this square c. So this is what we have. So it's just like what we have here, the multiplication as I've done here, just similar to that. So we are saying that if we have a set S and you have these operations, a set which is these two binary operations are defined on this set, and we take every 3 element from this set, and we have this, and this is the same as this for every 3 element belong to the set. Then we say that what the operation of a square, operation square is what? Distributive over triangle. That's what I say. We say that the operation square is distributive over triangle. Note that in the set of real numbers. So in the set of real numbers, this is what I've already explained. If A, B, C, A, B, C, if we take 3 real numbers, 3 numbers from the set of real numbers A, B, C, we have this. This is multiplication, the same as what I wrote. This is the same as what A into bracket what? B plus C. So I just brought this multiplication sign so that you know it will be in this form, so that you appreciate that one very well. So I could have written this as this. I could have written this one as this. Okay, the same, but this is multiplication sign here. Yes, that's why I brought it here. So if you have this, then this is equal to what? A times B, A times B into bracket, then you bring the plus, then A, this A times what? C. This is what we have. Have you seen? Yes. So with respect to the set of real numbers, this is always true. This is always true. So we are saying that, which means that multiplication, so which is distributive over which? We are distributing this multiplication over this addition. Have you seen? So we are expanding. So when we come here, multiplication is here, multiplication is here, and then we have addition. So the multiplication is distributive over addition. So which means that multiplication is what? Distributive over addition. Also, this, if you have this, have you seen? This one is the same as what? A into bracket what? B minus C. So if you expand, what do you get? You get A times what? B. To bracket then minus what? A times what? Times C. So we are distributing what? Multiplication over subtraction. Have you seen? So here we are distributing multiplication over subtraction. So also this A into, which is this they are equal, these two they are equal. But because there's a multiplication sign here, that's why I brought it here. So you know that you understand, so that you be in this form. So this one, the square, now the square is what? The square is the multiplication, and then the triangle is what? Is the subtraction. When you come here, the square is also what? The multiplication here, and then this triangle is what? Addition. So but here the square is what? Multiplication, and then the triangle is subtraction. So if you have this and you expand, you distribute multiplication over subtraction. This is what you get. Have you seen? Yes. And then with a set of what? With respect to the set of real numbers of rational numbers, this is always true. So we are saying that also is what? Which means that multiplication is what? Is distributive over addition. Also, this is equal to this, which implies that what? Multiplication is also what? Distributive over subtraction. Also, on the set of sets, intersection is distributive over union, and what? Union is distributive over intersection. In other words, intersection is distributive over union, and vice versa. Okay? Yes. Why? Because if you have this, A intersection. If you have 3 sets A, B, and C. If you have 3 sets A, B, and C, then you want to find this A intersection into bracket B union C. It's the same as what? If you expand, you have A intersection B, you have this, and then the union, then into bracket what? This A intersection was C. So yes, so we are distributing intersection over union. And so yes, so if you can just give an example, just define this set A, B, and C, and find these things, you understand that you get the result. This thing will be equal to this. Have you seen? Yes. So we are saying that over here, since A intersection, so if you have this 3 set, just find B union C. If you find the answer you get, combine it with A and find the intersection. Put your answer down. Come and find A intersection B, and then find A intersection C. When you find the answer, the result you get, find their union. And you realize that you get the same thing. So we are saying that since A intersection into bracket B union C is the same as A intersection B into bracket union to bracket what? A intersection C. We are saying that in the set of what? Of sets, intersection is what? Distributive over what? Union. The same way, if you find what? B intersection C, and the result you combine and find A union B. The answer you get, if you put it down and you come and find out A union B, you find A union C, and then the result you find their intersection, you get the same result. So we are saying that in the set of what set, intersection is distributive over union, and union is also what distributive over intersection. That's what we are saying, guys. I hope you are following, you are getting understanding, as the name of the channel implies. Yes. So what you have to know is that if you talk about commutative property, then we are saying that commutative, if A, for example, put A times B the same as B times A. So commutative property, we have two elements with what one operation. There's two elements with what one operation, and then another was one element with what two elements. With associative property, you have what one operation with what three elements, and with distributive property, you have what two operations with what three elements. That's what you have to know. You have to know that if you note this one, it will not confuse you. Otherwise, you might get confused when you ask to ask the right expression. Yes. So that is what it means. So we see here we have the operation. We have the operation of two operations, intersection and union. We have three elements or three sets A, B, and C. That's what we have. So over here, we have what three elements A, B, and C, and we have two operations, multiplication and subtraction. Over here, we have three elements A, B, and C, and two operations, multiplication and addition. Yes, guys, this is not difficult at all. Hope guys you are enjoying. Don't forget to subscribe to the channel. The only thing you can let me know that you are benefiting is by subscribing, by liking, and by sharing. Yes. Thank you for watching. We will explain it further. We solve more examples in the subsequent video. After that, we solve final exam questions to make you understand, make you get solid understanding. Yes, and the name of the channel implies every topic that is going to be treated here on this channel, but you will understand and enjoy, because after all, understanding is fun. If you have understanding, you have fun. Yes. Thank you for watching, and see you in the next video, guys.